Welcome to the second part of current electricity. So far, we have looked at the introduction to electricity. We also looked at static electricity. We did an introduction to current electricity. Okay, not an introduction. We did a portion of current electricity and we're going to finish it here. So this video is dedicated to studying a special part of current electricity which analyzes circuits, electric circuits. Then in the next video, we're going to take a look at practical electricity. Let's get started. So there are two types of connections when we're talking about circuits. The first is series, the second is parallel. So we're going to start with series circuit. An example of how series circuit is this kind of connection here. So in series circuit, all components are connected in the same line. By that I mean one after another. To add more light, in series circuit, there's no branching. You won't see a wire that taps somewhere and goes, or a wire that taps here and goes. So in series circuit, there's just one continuous path through which electricity flows. All right, so the job is to understand the behavior of voltage, current, and resistance in series circuit, how to analyze each of these three. So I'm going to start with current. So the current in a series circuit is the same at all points. What this means is at every point in this circuit, the current is the same. So the current that passes through the battery is the same current that passes through this resistor, and it's the same current that passes through this resistor. You can view current to be like volume of water that is flowing, let's say in a trench or a stream. So the amount of water here is the same everywhere because there's no any other direction in which there's no other path where water is flowing. Okay, so so from now onwards, when we're talking about the flow of or the behavior of current, we should think of the volume of water in a pipe. So we can view this circuit, these wires, to be pipes. So the amount of water at every point is the same. It cannot change unless you connect another pipe that takes the water somewhere else. And that is where the other type of circuit called parallel circuit will come in. Okay, so in conclusion, the current which passes through the battery is the same as the current that passes through resistor current 1, and it is the same as the current that passes through resistor 2 current 2. The second is the voltage. So the sum of the potential differences of voltage across the resistors is the same as the EMF. So for the voltage, we have the EMF, which is the voltage that the battery provides to the entire cell. Okay, so this voltage which the battery provides to the entire cell is shared by the various components of the cell. So this resistor is going to get part of that voltage, and this resistor is going to get part of that voltage. Therefore, if you don't know the voltage that the cell is providing, then the sum of these, when you add them, they should give you the voltage that this is providing. So that's what this statement means. So EMF is equal to voltage through resistor 1 plus voltage at resistor 2. Okay, so this is the second, this is how to analyze voltage in series circuit. The last one is how to analyze resistors. So the total resistance R of the components connected in series, that is in any series circuit. If you want to know the total resistance, you just add the values for each of the resistors. So R is equal to resistor 1 plus resistor 2. That's how to analyze series circuit. Let's take a look at an example. So I've got this connection. The question is find the total resistance. Second question is the current through the cell. Question C, the potential difference of 1 ohm resistor. And the final question is the potential difference of 3 ohm resistor. So here are the solutions. We're going to start with the total resistance. The total resistance is just you add the two resistors. If there were 3, you could have added the 3. Just like that, you just add them. So resistance, which is total resistance, is equal to resistor 1 plus resistor 2, which is 1 ohm plus 3 ohm, which is going to give you 4 ohms. The second question is the current through the cell. The current through the cell. Remember, the current provided here is the same. So how do we tell the current? If we knew the voltage here, we could have used Ohm's law to calculate the current that passes here, since we know the resistance here 1 ohm. Okay, and the voltage here we can use. If we know the voltage here, we can find the current. The answer that you should get should be the same as here if you know the voltage here. But since we don't know the voltage here and the voltage here, but we know the voltage here, we can use the total resistance. So if we know the total resistance and the total voltage, then we can find the total current. Since the total current is actually, using the total current is not right, we just have a single current that passes throughout the cell. So using this total resistance, we found 4 ohms, and this 12 volts we have, we can use Ohm's law, where we say current is equal to voltage over resistance. Remember this one, that formula, V is equal to IR. So I've solved for I, have V over R. V is 12, R is 4. You divide, you get 3 amps. So the current flowing throughout the cell is 3 amps. So once we know the current, we can analyze a lot of things, since we know current which is present everywhere. Question C, the potential difference of 1 ohm resistor. Potential difference here, we know the current that passes here is the current that passes throughout the cell, which is 3 amps. So to get the potential difference, we use Ohm's law. So we say voltage is equal to current times resistor. So I add in ones just to show that we're talking about the 1 ohm resistor. So the current the current is 3 amps multiplied by 1 ohm. I put the value of resistor in front, but it doesn't change anything. It's supposed to be 3 times 1, but it doesn't change anything anyway. So 1 times 3 is 3 volts. So that's the potential difference here, or the voltage here. The next is the voltage here. You do the same, use the current and the resistance here, so which is 3 times 3, 9 volts. Alternatively, if you know the voltage here and the voltage here, this voltage is the one that is being pushed to all the components. So if we know the voltage here, and we know that when you add this voltage and this voltage, they should give you the EMF. So we can say EMF is equal to voltage 1 plus voltage 2. With that being said, what is the EMF is 12 volts, voltage 1 of calculated to be 9 volts. What about voltage 2? So we can just solve for voltage 2. We're going to have EMF minus voltage 1. So 12 volts minus 3 is going to give you 9 volts. So I think the faster one is this. Next, we look at parallel circuits. So parallel circuits have this kind of connection. The components are not arranged one after the other. As you can see, everything is okay, but when we reach here, the components are parallel to each other. So this kind of connection is called parallel connection or parallel circuit. So how do we analyze the various parameters of parallel circuit? So we're going to start again with current. So the current in the main circuit is the sum of the currents in the separate branches. So the current in the main circuit, like the current that passes through the battery, is the current in the branches. How so? Again, think of these as pipes and think of current as water. So if this water, let's say it's 2 liters of water is flowing, when it reaches here, part of it will go this direction, part of it will go this direction. So there will be different amounts of water, different volumes of water. So the currents are going to be different. But when you add these currents, they should give you this. So this current, when it comes here, it divides. Part of it goes this side, part of it goes this side, but here it reunites and continues and passes through the battery. So the current here, which is the current through the battery, is the same current that comes here, but here they divide. So that's what this point means. The current in the main circuit is this part, is the sum of the currents in the separate branches. So current is equal to current 1 plus current 2. What about voltage? For voltage, it is opposite to current. So for voltage, this provides the voltage. So is that voltage divided by the two cells? No. Voltage is like the forces between 2 points. Remember the meaning of potential difference, the difference in potentials between 2 points. So if you look at this component and this component, they are both connected to here and here. So the potential difference between here and here should be the same. If this has a different voltage and this one has a different voltage, it implies that the potential where this is connected here and here is different from the potential that this is connected, but they are connected at the same point, so they should have the same potential. So V1 should always be V2. If there were 5, all the voltages of the components that are coming here and here should be the same. Therefore, voltage, which is EMF is equal to voltage 1, which is equal to voltage 2. So the voltage between the two components are equal to EMF. Lastly, we look at resistance. So for resistance, the total resistance for components that are in parallel, you get it using this formula. So you say 1 over total resistance is equal to 1 over resistor 1 plus 1 over resistor 2. So start solving and the likes. So for those who are not good at, who are good at mastering this, when you solve it for RT, you are going to have this. RT is equal to resistor 1 times resistor 2 over resistor 1 plus resistor 2. So this is how to get the total resistance. Here's an example. Start the circuit below. So this is a circuit to have 1 ohm resistor, 3 ohm resistor, and 12 volts. Find the total resistance, the potential difference of 1 ohm resistor, the potential difference of 3 ohm resistor, the current through 1 ohm resistor, the current through 3 ohm resistor, the current through the cells. So let's see how to tackle. So start with the total resistance. So the total resistance, we use the formula here. So we're going to say I'll use the difficult one, not the one that for that is straightforward. So 1 over is equal to 1 over 1 plus 1 over 2. So R1 is 1 and R2 is 3. So when we punch in, actually I chose R1 to be 3 and R2 to be 1. So these are fractions. Common denominator is 3. So common denominator is 3. 3 into 3 it's 1. 1 times 1 is 1 plus 1 into 3. 3 times 1 3. Actually, you guys, you have calculators during exams, so you can just punch 1 over 3 plus 1 over 1. You're going to get 4 over 3. Or if you want, you can convert this to decimals, or 4 divided by 3. It's going to give you actually, before you do that, here is what to do. We have 1 over r is equal to 4 over 3. So you take r upwards, 1, you bring it down. Okay, you swap the position of r and 1. When you do that, do the same here so that things are in balance. You can't just swap here, then here, you leave it like that. So you take r up, 1, you bring it down. You do the same, take 3 up, 4, you bring it down. So this is going to be r over 1, which is just r, is equal to 3 over 4. 3 divided by 4, it's 0.75 ohms. That's the total resistance. If you use that other formula, it will directly give you this. So that one is far much better. So the current through, if I skip some question, if I have, sorry. Anyway, let's try to solve the current through the 1 ohm resistor. So the current through the 1 ohm resistor, the current through the 1 ohm resistor. So they want us to calculate the current through the 1 ohm resistor. We know the total resistance and the total voltage. Okay, so we can find first the total current in the main circuit. That thinking won't help us. Yes, so I was analyzing using the series kind of thinking that if we find the total current in the main circuit, then we're going to be able to get the current through here. So the easiest way is to use Ohm's law here. We know the voltage through the 2 points is the same as the EMF, the 12 volts. So we can use that voltage, and the resistance here will get the current. So say current through resistor 1, we're going to call the current as current 1 is equal to voltage over resistor 1. So voltage here is going to be 12 volts, and resistor 1, again, you have used the 1 ohm as resistor 1 ohm. So 1 ohm divided by 12 volts is going to give us 12 amps as the current through resistor 1. The current through the 3 ohm resistor, we do the same for the 3 ohm resistor. So we can say 3 ohm resistor is equal to voltage over resistor 3. So voltage, again, 12 volts divided by 3. So 12 divided by 3 is going to be 4 amps. Last question is the current through the cells. So the current through the cells is just the summation of the currents. So we can say current is equal to current 1 plus current 2, because the current here and the current here are joining here, which makes the current through the cell. So current 1 plus current 2 is going to give us 12 plus 4, which is 16 amps. Alternatively, you can use the total resistance you had gotten and the total voltage. So you can say total voltage divided by total resistance. It will give you the total current that passes through the circuit. So total current is equal to 12 volts divided by 0.75 still gives you 16 amps. So hope I haven't skipped some question. I think I have. So I think the other question was about the potential difference in the 1 ohm resistor. So the potential difference in the 1 ohm resistor is the 12 volts. Okay, the 12 volts that was on our cells here, because the 12 volts is the voltage here, the EMF is the same as the voltage here and the same as the voltage here. So the voltage here is 12 volts, the voltage here is 12 volts, and the EMF is 12 volts. So this is how to analyze parallel connections. So this marks the end of part 3 of electricity. Hope you have enjoyed. In the next video, which is practical electricity, we're going to take a look at interesting stuffs about things that we might already know about electricity, because it's the electricity that we use in our homes. Happy solving.